The next ground rule on our list has to do with Lewis structures that involve the element oxygen. So oxygen is happy at 6. So going previously, carbon was happy at 4, nitrogen happy at 5, oxygen is going to be happy at 6, and so do all the elements below it. So sulfur and selenium will also be happy at 6. So how will oxygen be happy at 6? So we will have an oxygen here, 1, 2, 3, 4, and then I'm going to put the other one here for 5, and then the other one at the bottom at 6. So nitrogen, if you remember from the previous video, had one lone pair to consider, which will really affect the geometry when this when we draw these in 3D. Oxygen with 2 lone pairs will even more significantly affect the 3D structure of the molecule. So I'm going to put this electron and that electron as ready to form a bond, and it could form a bond with anything, so really doesn't matter what the R's are. Let's do some concrete examples here. The most famous concrete example, at least in my estimation, has to do with substituting the R groups here with water, with hydrogens. So if you substitute it with hydrogens, you're going to get the classic molecule of water. Water is not a linear molecule. It actually has a 3-dimensional structure known as bent. It turns out that 2 lone pairs bend in the molecule. So if you really want to get 3D in a 3-dimensional manner, because all these molecules have a 3-dimensional geometry to them, if you really want to get 3D about this, it's bent. The 2 lone pairs bend the molecule. They distort the shape. So this is really the correct geometry reflecting the water molecule. All right, always we're worried about 2 things, and here we're talking about the oxygen atom and how it's happy at 6. We want to focus on formal charge and octet rule, out of which the formal charge is most important. So let's do our formal charge considerations. So formal charge, okay, this is going to be 1, 2, 3, 4, 5, and 6. So oxygen is happy at 6. 6 minus 6 is 0. So the formal charge of that molecule, oxygen in water, is going to be 0. The second rule is going to be making sure you can get an 8 around the atom, though there are examples of expanded octets. So, this rule is not hard and fast, but the formal charge minimization, that has to be very much adhered to. So the octet rule, here we count everything around it, shared and unshared, as 1. So counting them individually for the octet rule, 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen has an octet. Let's do another example. The other example would be formaldehyde. Looking at the structure of formaldehyde, remember we've got our 2 lone pairs, but the oxygen is forming a double bond. So this construction of formaldehyde, that molecule, we want to minimize the formal charge. So let's do that consideration. So we have 1, 2, 3, 4, 5, 6. So oxygen is happy at 6. 6 minus 6 is 0. All right, so that's a good place to be in for the oxygen of formaldehyde. And then for the oxygen now here, the octet rule, let's count them everything individually. 1, 2, 3, 4, 5, 6, 7, 8. So this satisfies the octet rule. Okay, let's do one more structure here. That's the hydroxide ion. Remember from your flashcards, okay, way back in the first week of class, we had in our flashcards something known as the hydroxide ion, right? OH minus. So how will we draw the Lewis structure of this? Notice the minus sign. If you remember from your flashcards, OH has a minus sign, and that minus sign is one entity, one unit. So oxygen is happy at 6. Hydrogen is happy at 1. Okay, it's actually the first element here, so this is going to be happy at 1. Hydrogen is going to be happy at 1, and that minus sign means you gain an electron, so we're going to have to add 1 electron here. So 6 plus 1 is 7. 7 plus 1 is 8. So we got to put 8 valence electrons around the hydroxide ion. Remember, the minus sign gains an electron. Hydrogen, as we learn in a future video or right now, we'll learn it's happy at 1. Oxygen, we have to memorize, is happy at 6. So how will we do that? So we have an oxygen bounded to a hydrogen. And now we're going to put, let's see, that's 1, 2. Okay, so we need 6 more. The 6 will actually go on the oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. These are my 8 valence electrons that are around the hydroxide ion. So a very interesting thing here when we do our formal charge and the octet rule. Let's first do the octet rule. Looking at this oxygen here, 1, 2, 3, 4, 5, 6, 7, 8. Right? 1, 2, 3, 4, 5, 6, 7, 8. So for the oxygen, we're at an octet. Hydrogen is an exception to the octet rule. Hydrogen, the octet is actually 2. So 1, 2, and that is the octet for the hydrogen. That's what I mentioned to you before at the very beginning. There's a lot of exceptions to the octet rule. Very beginning meaning this is definitely, we can have an expanded octet, but we do have violations. Hydrogen is a violation. Hydrogen is happy at 2 with regards to the octet rule. Okay, let's look at the formal charge. Okay, we got to do the formal charge of the hydrogen and the formal charge of the oxygen. Since this video is mostly focused on the oxygen, let's do the formal charge of the oxygen first. So the formal charge of the oxygen, 1, 2, 3, 4, 5, 6, 7. Once again, 1, 2, 3, 4, 5, 6, 7. Oxygen is happy at 6. 6 minus 7 is minus 1. So the formal charge on this oxygen is minus 1. And that's where we have that negative sign, the hydroxide ions, when we did our flashcards. It's formal charge considerations. So oxygen, when it forms Lewis structures, it can form a single bond. It can form a double bond, as in formaldehyde. And single bonds, most famous example will be water. Here the 2 lone pairs really distort the structure of the water molecule. So in the next video we're going to focus on hydrogen, its formal charge and its octet, though again it's a violation because hydrogen is happy at 1 and the octet rule for hydrogen is only 2.